Good afternoon, Packaging 450. Glad to be here again for lecture number 8. Before I go any further, I have to mention I have on one of my favorite t-shirts today. It's not cardboard, it's called corrugated. So some little packaging humor there. You all get into it once you're getting out working. After a few years, you'll like jokes like that. Anyway, I wanted to continue with chapter 3. We just started talking about some of the testing, and I will share my screen. All right. Can you see, Brandon? Just want to make sure you're our guinea pig for the class.
Yep, I can see.
Okay, great. All righty. So I just want to review a little bit. AIAG RC9, that is a guideline that the Automotive Industry Action Group, and click on that link. In fact, I'm going to click on that link now. Or I guess I'll just copy and paste because that link is not working. And pull it up so you all can kind of see what AIAG consists of. Okay, so this is the website for the Automotive Industry Action Group. I will log in, maybe, and show you, okay, show you what is in here. I'm lying to you all. I think because I'm filming it slowed everything down. But okay, so when you go in, this is what you see. I have a login and a membership to AIAG, so I can access some things in here. I think you can actually, if you go to the store, you can see all these products, but there's a different cost if you are a member versus a non-member, but you can still see some of the things are free for download. So I'm just going to type in RC, which stands for returnable container. So you can see, so here is a packaging data form, which is a format people use to supply, say a tier would send this to an OEM, or tier two would receive it from a tier 1, and it gives a list of all the information that would go with the packaging for a particular part. Then this is the pallet standard I think I mentioned before. There are guidelines for returnable container management. Here's the RC9 that we've been talking about. That guideline. This is just a lot of different information that you can see. This is specifically returnable containers, which is what the RC stands for. AIAG, they are really good about having information available for people in the field. And also they have seminars, they have various conferences that you can attend as well. It's got a lot of information for automotive in general, a lot with quality, supplier information. But then, like I said, there is a whole section just for supply chain, and that is what the packaging falls under. You can see here, besides the store or publications for the standards and guidelines that they make, they also have different groups. So, even finished vehicle logistics, there's like a whole section on finished vehicles, material management, which some of the packaging falls under as well. Okay, so you can see here under materials management, when you go to this drop down, you have packaging and labeling. So there are label standards, those pallet and carton standards that I talked about will go there. You can see a lot of their packaging information under materials management has to do with things like the labels and RFID tracking so you can track your containers. So the materials management team, they're usually in charge of all the parts and making sure they have the right parts in the right place at the right time. And a key part of that is the packaging, having the right packaging, the amount of packaging they need, as well as making sure that those packages are labeled or shipped with an RFID reader or however they can track. So when you go into the pallet and carton standards, you'll see the 4 that I talked about already. So mostly dealing with pallets. The RC9 is under there as well, so they'll have it in multiple places. They have some more for returnables. This is an international standard for returnable containers. Let's see. Okay, so here, returnable containers transported by truck. The specs define the overall dimensions, layout, sizes, and materials. So that's where we talk about all these standards that you see, even though this is 1/10 of the size of what they're using, it's still, they all nest and fit on each other because they all have the same footprint. And that is because they know it will maximize the size of a trailer. And if you can buy totes or bins from multiple suppliers and they will be the same size. And even if you buy one and for some reason they get mixed up, or maybe you start a new vehicle and you have existing containers and you need to add more, maybe the best price is coming from, you have old containers from supplier A that are really just fine and good to use, but you don't have enough, so you need to buy more. But the price with supplier B is now cheaper. You are guaranteed to know that they fit in the same footprint. You should be able to fit the same amount of parts in them, so on and so forth. So that's why they stress this sort of guideline for automotive packaging. Let's see what else they have before I move on. Let's see. So these are active projects. So when they say active projects, there will be committees that are working to update or define or create new specifications. This supply chain steering committee, I was on that at one point. They cover everything related to supply chain, from packaging, even to what's called yard management. So there is a whole area just on how the trucks are managed, how the trucks come into the facility, to make sure that they're safe, to make sure that unplanned trucks don't show up and either take things or steal things or come in when they're not supposed to be in the facility. And then also, how do you track these containers? And when I say containers, I'm saying like the containers that are attached to the tractor trailer. They will be out on a lot, and you might walk out onto a lot. You've probably been to a plant and you walk into the back lot and they have trailers everywhere. And how do you know what's in which one? So there's a whole system set up for automotive through AIAG where they talk about those things. So again, many of these committees, the charter is to drive awareness and implementation of industry best practices. So again, they're not setting rules that you have to abide by, but they're setting best practices so that there is some standardization and so that people can learn what worked well at that company. Maybe I can implement it at my company and make it better. So that is it for AIAG, but I wanted you to get an idea. So, feel free to go in there to the website, poke around, see what you see. And if you have any questions, please let me know. Oh, speaking of questions, before I go any further, I've received a couple of questions from people regarding the fact that for packaging 450, you have to sign up for 2 courses. So one is packaging 450, and then the other one is special projects, which is worth 1 credit. The question I've received multiple times is, do I have to do anything separate for the special projects course? And the answer is no. Everything is wrapped up under the content for packaging 450. The only reason why we are doing the special topics is to get this class to be a 3 credit course, because apparently in the past it was a 2 credit course. We've added a little bit of content regarding fleet calculations, returnable container management, and those things, and updated it with supplemental information. So, that brings it up to a 3 credit course, but that is it. As far as students are concerned, this class, everything is wrapped up in what is on D2L for PKG 450. And that means that whatever grade you get from that, you're going to end up getting the grade for those 3 credits, if that makes any sense. If you have more questions, let me know, but I just wanted to clarify that before I went any further. Okay, so talked about AIAG, dig into that, check it out, get to know what's there. There are a couple of other industry groups that have cropped up in the Southeast, because a lot of the automotive companies have either built new or additional facilities in the Southeast, which would include like Alabama, Georgia, and the Carolinas. So basically there's a swath up in the Southeast where if you drive along I-20, I-85 in that area of the country, there will be a lot of automotive companies, and many of them you have like Volvo, Mercedes, Hyundai, Kia. So many of them are outside of, from other countries, and they've moved here. And instead of moving to Michigan, they opted to move south because of basically because of labor. I will tell you though, that when they moved down there, they ended up opening a lot of training, because a lot of the schools here were set up for people to move to automotive. So they trained in preparation and anticipation of that. So some of these automotive organizations have cropped up to do some of the things that AIAG is doing, but also just to make sure that people have the skill sets that are, pretty common in the Michigan area because of automotive. But some of those organizations would be AAMA, which is Alabama Automobile Manufacturing Association, and then GAMA, which is Georgia's version of that. So those, those are just a couple. So they do things similar to some of the things AIAG does, but not everything. Okay, so back to this. So again, these are performance guidelines, and these tests are based on the standards. So these standards from ASTM, those are actual standards. So those are standards that are used by test facilities, and they follow those tests 100% to the letter. So what you have here for RC9, they are giving guidelines for the tests that they recommend being used. So whatever tests are recommended, once you get to ASTM testing, you are following this to the letter. And any lab that is doing an ASTM or an ISTA test, they are all they're doing the exact same thing. They may have a slightly different equipment, but that equipment has to perform to the rigorous test standards that were set aside, set in place by ASTM or ISTA. Okay, so these are the references. We went over some of them yesterday. We went over D4169 specifically. But you can Google these and look them up if you just want to see what they look like. But then for the RC9, as I mentioned yesterday, there are 10 separate tests. And most of those tests, you have to do them 5 times. So they have to be repeatable so that you know for sure that, if you test once and it passes, you want to make sure you retest it and it passes because, maybe that was a fluke. Or if you test it, one time and it fails, you want to test again. Maybe that was a fluke. Maybe the other 4 times it doesn't fail. But if you get a consistent failure, and it's statistically significant, then you know that there's something that you have to do something to change your packaging, or change the part to make sure it's more robust and it can withstand the transit environment and the handling environment. We mentioned again before yesterday that the conditions of the 72 degrees and the 50% relative humidity, which is fairly standard, that has to be, the conditions have to be that way so that you're comparing apples to apples. So if you test the pack in Minnesota in the wintertime, you're going to get very similar tests if you test, say, a corrugated box. If you tested in Florida in July, the humidity is outside is totally different. So if you if you make the temperature the same, it equalizes what you are testing. Okay, we mentioned the weights, and I mentioned that came in because with the weights, if you don't have your parts, if you don't have prototype parts, if you don't have production intent parts, but you know that you have, I don't know, a 6-month lead time on getting your racks or getting tooling in for an injection molded pack, or for some dunnage. If you can't meet that lead time, you have to know what the lead times are in general for your packaging. And if you can't get parts and tested in time, then waiting is an option. I've never seen this happen personally because I will say I've worked for fairly large tiers and OEMs in automotive. So they have suppliers that they work with that kind of anticipate what is going to happen. So they're able to either get some sort of either sample parts that are very similar or, something along that line. But, every once in a while you do come across something like this. So I have one client that they're somewhat in startup mode, and getting samples is really, really difficult. So we had some transit testing we were going to do about 3 weeks ago, and parts weren't available. So, now everyone's kind of scrambling, and I've been telling them it's really important to get these parts. And then they're like, can we just get one? Because what if it breaks? And I tell them, and this is not on the homework, but this is something that if you're going to work in not just automotive or industrial, but any company, you want to stress that you'd rather test a full box of 5 now than to wait, not test it, or test it with just one. And maybe, there's a vulnerability in one of those positions that you did put a part in. And then you end up shipping it and those parts are getting damaged once you start shipping full scale production. So I tell them you'd rather test a few in a full box early on than to not test a full box, because it's much better than if you don't test it and then you get damaged when you're in shipment. So that's one thing I definitely want to stress with you. Okay, so the first test, we talked about this a little bit. This is the stacked impact test. And I'm not sure why okay, here we go. This is done on a horizontal impact tester. There's a wooden post that you have on that sled wall as well. And it's actually put in a very specific position because you want it to simulate what's going to happen if a fork truck driver puts another container on top of it, and then they run into another, pallet or wall or post or whatever they could run into. You just want to simulate that. So that's what this simulates. And this is, again, these tests are for the bins, those 48 by 45 bins. This isn't totes, this isn't pallets. These are the large 48, 45 bins, and it can be with or without the doors. So as I mentioned, if the bin has a door, you want to make sure that the side with the access door is facing the sled. So because you want to see if there's a difference. You want to see if an impact to the access door has, if it causes damage. That is one of the most common repairs on these bulk bins that have access doors. When you look at replacement parts for those bins, one of the replacement parts is actually for hinges, because those hinges are prone. They don't break all the time, but if there's going to be breakage, that's one of the most common types of breakage. And they've made it so that you can just replace the hinges versus throwing away this whole bin that costs $150 or $175. You can replace it with a bin for much less than that. Okay. So I would suggest that you read through this and just be aware of this. It's not necessarily anything I see used in the industry, but the homework does reference these test methods. And if you were doing a test, what would you do? And that's important because, like I said, unless you're working in the test lab, you're not going to memorize all these tests and know these processes and procedures like the back of your hand. But if you are on the design side, supplier side, and you need to get transit testing, you want to make sure that you understand how these tests work in combination with understanding your supply chain. Like I said, are you shipping just on a plane, or are you going on a barge, on a boat, on a truck, on a train? Once you understand that, then you can figure out which test most closely mirror what your shipping value stream or supply chain looks like. So, you want to look at the things like like what is this weight increment here? The weight increments equal to 7% of your EFW. So, those are some things that you might want to remember as you work through this. Look at the different increments and understand, think about what does that do for you when a test is running. What does that simulate, and what are you trying to look for? For one thing, when you're doing these increments, you're trying to look for, where is the failure? If the failure is going to occur, where does it occur? And if you just go from light to heavy and you test it at a very lightweight and nothing happens, but then you test it when it's heavy, well, how do you know exactly when that event will occur? So you want to try to do this in increments so you can see if failure is going to occur, where it will occur. So, here you're looking at, once it fails, you've got the estimated failure weight and then the actual failure weight. And that's where you're looking at where that damage occurred. And then you want to make sure that, you run your test again 5 times. You want to have 5 replications, and you're testing to make sure there's no damage. Because once you get to that point where, okay, something got damaged, now you're trying to find out, okay, when exactly did it happen? And if I have a design and a weight of A, and I know it gets damaged, and I back that out until I find out exactly when it's safe and it won't get damaged. So that's what you're looking for. Number two is the sidewall impact. So again, you're looking at the sidewalls. This example shows with an access door, and I wish I had a mini one with an access door, but I don't. So you've got the post here, and you're trying to again have an impact event to look for failure. You're doing it in multiple orientations. So you want to make sure that you do the impact on the side with those access doors. And that way you're testing those hinges. And then you also want to make sure you do another side. So with a lot of this, you're testing the durability of this bin, right? But if the bin is durable enough, then you're ensured that your product will be safe as well. So that's the whole point. You want to make sure that you don't have damage to the bin during transit, and then the bin, which before it's damaged, it's able to withstand impacts or it's able to withstand compression. Let's say this gets halfway through transit and it breaks. Now this is bearing the weight, not just of what's in this bin, but it's also bearing whatever's on top of it. And the chances for failure are greater for that bottom bin. And then once that bottom bin fails, and maybe this bin either crushes what's inside of this bin or this falls off, now you're dealing with things like safety issues, spillage of the parts. The product is much higher likelihood of the product in both bins getting damaged at this point. Again, you're using the weight increments to figure out where your weight, where your damage might occur, and running through those impacts. And again, replicating this 5 times where you successfully complete, you want to make sure that you are getting your packaging is not getting damaged and it's passing 5 times. And again, you're gradually increasing those weights again. You can see the pattern here. So again, here, the goal of the first 2 tests is to establish a reliable weight, or the average weight of what you're packing, that will allow those containers to get transit tested and pass both of those tests during that transit testing sequence. Test 3, like I mentioned before, this is probably more similar to traditional drops, but these are bigger. So instead of someone carrying them around a hand tote or a box and dropping it by hand, we know that these bigger bins are going to get handled with fork trucks. So the drops are based more on how they're going to get handled with fork trucks. So when you think about it, fork trucks will pick up the product and then they will move it around. And when they move it around with the forks, they're handling with the forks. So when they set it down, there will be impacts, or they maybe are the driver sitting here, he can't see in front of him. Somebody puts it in a truck. It's hard to gauge how far into the truck. So he may hit a wall, he may hit another pallet, or even just dropping the bin down, on the ground or on the floor or on top of another pallet. Those are some of the things that you're looking at. Many times when they have the forks inside of their pack, they'll pick it up and they'll kind of tip it. And then when they get ready to release it, they'll slowly pull those forks out and then it will drop. So usually it's raised a little bit, they pull the fork out and then it drops to the ground or, wherever they're trying to get it. So this simulates that. So you can see you're going to use those same containers. One side gets lifted 8 inches, which is about what you would expect a fork truck to lift a bin like that. And then they pull out the forks and let it drop. Again, you want to focus on making sure that you have captured the behavior of this bin when you drop it on the access side. There are some tests where, I've seen it where they have blocks, they'll have wood blocks, and they prop it up because they want to get to the 4 inches versus the 8 inches. And that one, you're not trying to capture a weight like you were in test 1 and test 2. This one is a pass or fail. Okay, test 5 is vibration, which is probably what you all have talked about in previous packaging courses. You're following ASTM D4169 truck sequence, and it's going to be very similar to what you see for boxes or what you've probably done in a packaging lab class if you've already taken that class. And then this is what the curve looks like. Any questions, Brandon?
Nope, my bad.
Okay, so number 6 is fatigue compression. Again, this is another test of failure. And you're not trying to simulate, imitate like you do with the forks. And even, with test 1 and test 2, where you're trying to make it as close to real life as possible, but repeatable at the same time, looking at impacts or what kind of damage you would have during these events. So this one is, compression test. It's going to look, I would say it's going to look a lot different than what you are probably used to seeing for corrugated, because, the plastic containers are stronger. So, where a box this size, even if it's triple wall, you're going to see more damage or more failure if you ship metal parts in a triple wall corrugated box than if you ship something in a returnable container like this. They're more durable. And even, like I said, I mentioned yesterday about the wraps, where you might have a corrugated or plastic corrugated wrap that goes around a base pallet, and it looks like a bin from a distance because the wrap is attached into the pallet, but it's really like a 2 or 3 piece pack, and then there's a lid on it. So your compression test for a corrugated box versus something like this versus a sleeve wrap would be different. And again, you're doing a pass or fail for this one. And it's compressed to what you anticipate the load will be, because you're simulating, you're trying to understand, how does this pack perform? You're not trying to see what makes it fail. Okay. So this one, the next one, test number 8, this is a simulation test. So you're looking at things like time and temperature, and what does that do to a box or a pack or a bin over time. And this is important because you have multiple plants that maybe make the same part, shipping the same part from multiple places. So depending on how long they've been sitting in a warehouse. So again, Minnesota in the wintertime, something sitting in a plant there or in a warehouse there is going to look a lot different than a box that has been sitting in a warehouse in Florida in July. So, these are some of the things that you want to check for. For this one, you start off at the 72 degree Fahrenheit temperature, that's standard temperature, and then it gets elevated up to 120 degrees because that seems pretty hot. Well, maybe not now because of all the heat waves we're having, but the 120 degrees is a good guideline for a plant that is not air conditioned in a warm part of the world. 100 is not unreasonable for a building to get up to 120 degrees in the summertime if it's not air conditioned. So, and I'm going to go back a little bit, way back to chapter 1. We talked about Henry Ford and the working conditions, even though he revolutionized manufacturing for automobiles, the work environment was pretty rough. So in the video, they were talking about what a pleasant plant it was to be in, and they kept mentioning that it was air conditioned because that is a big deal. More and more plants are air conditioned now, but in the United States, and the large car companies will do that, but it's not uncommon for smaller companies or other countries to not have air conditioning in their manufacturing facilities. And even certain parts of the country, you might see there's not air conditioning, it's not fully air conditioned. It might be air conditioned when you first walk in the plant near the office, but the further you get into the plant, you get to the warehouse all the way to the back where the truck docks are, it may not be air conditioned. So that's why this is important, because you want to see at the different temperatures what kind of performance you're seeing as far as deflection. So you'll notice with the measurements, they're starting off with every 4 hours. I'm sorry, every hour for the first 4 hours, and then it starts to be every 24 hours after that. So what that says is over time, people have found that a good deal of the deflection happens pretty quickly early on. And then after that, it creeps, the changes creep, and you probably can't detect a change, maybe every 24 hours, depending on the box and the failure rate or the pack. But you will see, if you're going to see deflection, it usually happens pretty, you can see it and detect it every hour early on. That's what that tells me. The leg impact test is, this is where you're looking for bulk containers that have legs. So something like this, right? You want to see, how does, if someone comes with a fork truck on this side, even though it's not meant to be forked this way, and you can kind of tell because this has the slots, but technically you can pick it up with a fork this way. And if it's facing that way in a truck, they're going to pull it out that way. So what you're trying to see is if this gets hit with a fork, any of these legs, what does that do? Fork truck damage can be pretty significant. I've seen over the years that people will, file a complaint or file a claim because their product was damaged by forks. And, people say, well, how do we protect against fork trucks? It can be very challenging to have a plastic or wood-based pack get hit by a piece of metal from basically a truck, and for it not to have some sort of damage, significant damage. So it needs a special drop tester because you're looking at dropping a 400-pound weight. And that may seem like a lot, but actually, if you're in an environment where you're moving these containers with fork trucks, by the time you're using a fork truck on bulk containers, it's usually because it's besides the size, it's just too heavy for an individual to move by hand. So that is a fair number for sure. So, these are how the drops are made. And it goes all the way up. It starts at 4 inches and it goes all the way up to 32 inches. And it keeps hitting the same leg. And that might seem pretty extreme, but when you think about how often these containers are returned, and they're used over a minimum of a 5-year period. And some of these containers might be 10 years old or more. And depending on what the part is and the volume, these might be getting sent back in the loop every day. Worst case scenario, they might be getting sent back every day. So think about this getting used every day, getting forked every day over a 5+ year period. And when it gets handled, it's not just going to get picked up once. It's going to get picked up at the plant, at the tier 1, for example. They're going to move it around to get it to where they need to use to load it. It's going to get loaded with parts. And then once it's loaded with parts, the fork truck is going to pick it up again, move it, probably stage it somewhere near a truck. They may put it directly on a truck, but most likely going to put it down, pick it back up, another opportunity for the forks to hit any of these legs. And then once it gets picked up, put in a truck, moved into the truck, and then it gets delivered. And then when it gets delivered, someone comes with the fork truck, another opportunity again, moves it with the fork trucks out, probably stages it somewhere. Even if it's JIT, they may take it straight to the line, but most likely it's probably going to get staged somewhere to get taken to the line. So every single time it gets picked up and moved by a fork truck is an opportunity for that leg to get damaged. So imagine doing that. Say even if they don't do it every day, let's say they do it every once a week, this container gets returned, but just listing all the times that I've mentioned. So, now we've just gotten it from the supplier to, from the tier 1 to the OEM, and it's staged. Now they pick it up and they take it to the line. Then it gets emptied. Then they pick it up again and they take it somewhere, probably stage it for the return truck for empties. Then it gets put on the return truck. So now you repeat that cycle again. So just imagine doing that, even if you're doing it for once a week for a 5-year period, the opportunity to damage that leg is pretty significant. So when you look at what failure is interesting because it's defined as complete leg separation, which you would imagine, a 1/2-inch penetration of the fork tip, which doesn't seem like much, but if you got something that's a bin that's 48 by 45 inches and you've got 1,200 to 1,000 pounds of material in there, and one of these has been pierced 1/2 inch, that could actually compromise that container. And then also removal of a chunk of material bigger than 1 inch by 1 inch. So that would be, you'd have a chunk out of the corner or a hole in that. And this is my opinion, I'm just interjecting here, so it's not in the homework. If they're saying that an inch by 1 inch by 1 inch chunk is a failure, but this fork truck is the fork truck tines that are hitting it, they're more than an inch. They might be, 2 inches tall and 4 inches wide, even at the narrowest part, maybe 2 by 3. I don't remember what the dimensions are, but the chances of getting a chunk out of 1 by 1, if you hit it, it's probably going to be bigger than that. That's just my opinion. And again, you are looking for the drop height where this happened, and you got where you didn't have any damage. So again, as you see this container is on its side, this tip is assuming this is basically simulating the fork truck. And the reason why it's on its side is because it's easier to keep that still. And you can repeat that impact over and over again. Whereas if you took a fork and tried to hit the fork over and over again, you'd get, a variation. It wouldn't necessarily be as repeatable. Okay, so those are the 10 tests that are listed here. There are some other tests, and these are, again, I mentioned yesterday, for things like individual totes, totes that are on the plastic pallets, and even for the pallets. They're very similar because you're looking for the same thing. You're simulating, you're trying to find where the failure occurs. You're trying to see how much stress the pack can take. You're putting the weight in here. So, this is totes are loaded with 40 pounds of material and then tested. Interesting, because we talked before about the limitations of weight carrying around handhelds in an automotive plant. So 40 is going to be more than what most totes are. You will see totes that are over 30 pounds, but it's going to be very rare. And if they are, generally they're going to be put on a pallet, and that whole pallet might get moved. So, or it might be in an area where the basketball team is set up, and that basketball team is a reference to the Ford Rouge video where they have those tall guys working. So if you're seeing totes that are loaded more than 40 pounds, it's an exception to the rule, and they probably couldn't make any other accommodations to lower the weight. But this is going to be testing for worst case scenario, obviously, because of that. This is looking at cold temperatures, because these plastic bins are going to be more brittle in the colder conditions. So you're looking for failure in cold conditions. So again, when you see something like this in Minnesota in the wintertime versus Florida in the summertime, it's going to perform differently with the test like this. You got compression tests, you got the random vibration again. And again, you're using that, truck profile, level 1 truck profile. This one is when you have unit loads that have top caps on them. And I don't really talk a whole lot about it, but the best I can do is describe, it's not a pallet, but there's a cap, and you've seen pictures in the previous chapters where you have a lid. That lid is shaped, some can be used as a pallet and a lid. They're mirror images of each other, or they're identical, and you can use it either way. But generally, the lid, you can stack another either pallet, or you can stack another bulk bin on top of it. They're designed so that they all nest with each other and match. So this is a bad example, but you can see this is on here because they're actually made to nest together. Okay, so talk a little bit about plastic pallet tests, and I better do a question check. Brandon, any comments or questions at this point?
Good.
Okay, good. Okay, so your test for your plastic pallets, you're really looking for how do they handle themselves in distribution environments. You want to make sure that they can stand the test of time, literally, because these can be used for years and years and years, where some of these bulk bins or totes can get used for 5+ years. Same thing with these pallets. The pallet suppliers generally tend to test them out as well, but you want to make sure that they make it through your environment. And you're looking for, not just shipping, the distribution, but handling, with fork trucks. And then the third thing is the warehousing. So, we touched on that a little bit in chapter 2 about how the pallets need to fit on warehouse racking. And it can be an issue for a couple reasons. It could be dangerous if they don't fit right. They could fall, they could push other pallets off. When you load one on, it could push other pallets off. So there are just a lot of reasons why you want to make sure that the pallet can be not only fit on a warehouse rack, but also it is strong enough to hold the product on a warehouse rack. Okay. Okay, so this one is when you're looking at racking that can only hold two edges of the pallet. So like here and here, pretend this is a rack and it's only holding at these points. And you can see it's a compression test. You've got these posts with the steel poles, and once you compress it, you want to see what happens. And here's an example of one that is deflecting, and I'm going to guess this one's probably considered a failure. And that's what you're looking for. You want to know, where your failure is occurring. The next part of this, you have your pallet, and you have the same setup, changing your deflection and the way you measure it, and you put the load up for a period of time. So you're trying to see, over a long period of time, what that deflection looks like. And you want to see if there's any creep to your pallet. So whereas this pallet may seem solid, once you put something really heavy on it, it may start to deflect. So you can't really see it, but on here, I can press it. Yes, Brandon?
Do they mention at all what program is used to measure the deflection that's found from the testing?
No, they don't. I can probably try to find that, but most of the test labs, they might use, say, like Lancemont equipment, and Lancemont usually will provide like the whole setup, not just the compression.
Oh, gotcha. Makes sense.
Yeah.
So do you think this follows the same MOE that we always use? Same modulus of elasticity?
Yes.
Okay, cool.
So does that answer your question?
Yeah.
Okay, great question. So, again, this one you're looking at, are you, what is it going to take to cause that pallet to fail? And in this one, they're talking about the 6% failure here, or breakage. So basically saying if it's deflects, if you have more than 6% deflection, it's really considered failure, even if the pallet itself doesn't break. They know that fatigues the pallet enough. The pallets are made to withstand that much deflection. Anything after that could lead to long-term failure. Let's see. The next one, same thing. But instead of having a concentrated load, because that's what this simulates, you have a load that's spread across the whole pallet. And they're using an airbag for this one, in between the pallet and the platen for the compression test. This one went over a little bit yesterday. This one is, again, you'll see there are a lot of tests that are simulating fork truck, the performance of the pallet with the fork truck. So this is simulating, once it's picked up by a fork truck, how much weight can it withstand? And is it going to fail? The next one is you're looking at the stringers and the blocks on the pallet, and you want to know when it's compressed, how it's going to perform. And you're doing that one until it either breaks or you have deflection of over 10%. Part B, same thing, except that your load is 50% of that failure load. So whatever it took to make it fail, you're going to do 50% of that and see what happens then. And you're going to do it over 24 hours. So you can see these tests are pretty specific. Number 5 is going to determine how rigid the pallet is in the corners. Because as you know, corners are taking up a lot of the strength, but you also want to make sure that when the fork trucks, the chance of the forks hitting those corners is fairly high because the fork trucks don't have much space to work with. So you want to understand, you know, you're using plastic bins, totes, but sometimes you are going to be using, you know, corrugated boxes depending on what the part is. But if you're using a returnable pallet, then 99% of the time you're going to be using a matching returnable tote. But you're dropping these on the corners to see, you know, what happens, what kind of damage you get. Here's an example of some of the damage you might get. And you can see it's unseated from the base. Again, another one for edge impacts. So, you know, this one was top to bottom. This one, you're going to actually, you know, put the pallet on its side to hit that edge. And it's hitting a concrete slab because most of the facilities that these are going to be in are going to be, you know, they're going to have cement floors. So you want to, you know, concrete floors. You want to make sure that you see how they perform when they hit concrete. And you see the speed is 5 miles per hour, which is pretty typical in those plants I mentioned before. Sometimes they might take off governors so they can go faster on the fork trucks, but in general, 5 miles per hour is pretty standard because, you know, people walking can get out the way. The force of hitting someone, obviously you never want to get hit by a fork truck, but if you do, it's going to be a lot more survivable than if the fork truck's going 15 or 20 miles per hour. So they're looking for damage. You see there's no damage, then it, you know, it passes. And you know that you don't have to worry about issues with the pallet, like, you know, this right here. And you're shipping product on this, you know, what does that do for, you know, if you have another impact event, are you going to lose product? Okay, so here's the picture of the concrete slab. Okay, this one is looking at the static coefficients of friction. So you're looking at the, oh, actually, this is I'm sorry, this is the unpainted steel plate. It looks like, I'm trying to see here. Oh no, here it is. Okay, I'm sorry. So that's the concrete one, and you're trying to see what happens. This one, you want to see what it looks like when the pallet is sliding off the forks. So that's why you have that unpainted steel plate, because that's pretty much the same material that you can see on a fork tine. So you can see it here, the unpainted. So that's what this is simulating. And this could be, you have pallets stacked on top of pallets as an example. So you're trying to move those empty pallets so that you can put product on them. That if you have a pallet on top of this, the fork truck will put the tines in and it could drag across the top face of this pallet. And it also will measure, you know, underneath where those fork tines are, what it looks like, how much friction it takes. So you see they did one on the top and then they did one actually inside. So this would simulate having a pallet on top of a pallet and fork trucks picking it up, and then the one inside is gonna simulate, you know, having a product on a pallet and pulling the fork trucks out, the fork tines out from the fork truck. Really my favorite, 6-axis vibration testing. So this is when we talked about the beginning of the chapter about all the possible ways that the truck is moving and trying to simulate that, you know, what that looks like. And, you know, this is mentioning, you know, while you're trying to simulate it, it's not going to give you, it's not going to be representative of what's really happening in a truck. So again, if you have a vibration table that can move it omnidirectionally, then it's going to be a little bit better, but most vibration tables are just moving up and down. So you're not going to catch, you know, all the different movement in all the axes. The next one is this profile. It doesn't really capture, you know, what's actually happening. You know, the things that cause damage, you know, hitting, having a big jolt, hitting a pothole, running over a big curb, stopping suddenly, you know, any kind of impact like that, going uphill or downhill, you know, those events, shock events are pretty large, and that's usually what can cause the damage. The truck profile is just basically showing the truck bouncing along. So it's kind of like if you're riding in a car or riding on a bus and it's kind of bumpy, but nothing really bothers you. And all of a sudden you get a big bump and then, you know, like you hit your head on the top of the car. So that's kind of what this is. So this is simulating just riding in a car and just, you know, bouncing along, very small jolts that you probably get used to, you don't think much of. But the ones where you're actually slamming on the brakes or, you know, hitting your head on the top, or, you know, hitting your head on the steering, hitting your face on the steering wheel, or hitting your head on the windshield, that's basically the equivalent of that. You know, those things don't happen all the time. And when they do the testing, it's simulating mostly the standard car ride. You know, and so short of like hitting a resonance frequency, most of the time watching a vibration test is, you've probably seen it. I've described it to people as watching grass grow. So, you know, it can be, you know, it can be interesting if you've not seen it before and you want to actually see what's going on compared to the theory of it. It's good to see, but most of the time you're not going to see any major events happening. So again, the third one, it says that this third point is, it's true. You know, when you have a profile loaded in, it's for a specific part of the vehicle, you know, specific part of the truck, a specific truck, certain highway that's a certain way, the speed, you know, all those things were pre-recorded, and they're supposed to be representative of a typical truck ride, but there's not really a typical truck ride. So let's just say, you're driving home, you drive home from, you drive from your, from home from school, every weekend, go to do your laundry, and you drive the same route every weekend. And it gets pretty monotonous, but in the wintertime, it changes. Or if you leave and get on the highway, you get on the highway and you get close to home. If you live in a city, you get close to home and you just happen to time it right around rush hour. Now you have a lot of stop and go traffic. So, it can be different. Or if you're going home for a holiday and you go home and you leave on the Friday before the 4th of July, and people are already heading out for the week, for the whole weekend. Friday, they're making that their travel day to get to the lake. So now you've hit all the traffic going up north for the 4th of July. So the profiles are totally different, so you can be in the same car, but your ride driving that route is totally different than, when you take your two friends with you, and the friend that sits in the front seat, the passenger seat, versus someone sits in the back seat. And then vice versa, they switch seats on the way back. It's going to be a totally different trip. So, that's part of why, the plots help to estimate, and the testing helps to estimate and anticipate damage. But you have to keep in mind, that's another reason why it's important to, you can run the test in the lab to look for a catastrophic failure, but you also need to make sure you run testing on the road, on a route that you're going to be using. I've seen people run tests where, they do a lab test and then they take it and they send it on a truck across town and it passes. Okay, that's great. But in reality, when production starts, now you're going to be shipping this 500 miles. So it doesn't really simulate what's going to happen on the road. So these plots show, the differences, what it looks like if you have an air ride truck, right? The impacts are much less. This one is if you have a leaf spring truck, which has a, suspension that is not as soft of a ride as the air ride. So similar pattern, but bigger spikes. And then you can see a rail car, which is a little bit more even. And then here is a large plane, right? Like a big cargo plane. That's what it looks like. So this is saying, it's even harder to really simulate what is happening when you're shipping by ocean or rail as well, because for the ocean, for example, the environment is going to be different just based on what ocean it is, what time of year, where exactly they went, are they going along with, on the trade route with the, currents, the trade winds, or are they hitting a storm? Are they on the boat during monsoon season? Those sorts of things. Those can make a big difference. The same thing with, rail cars. So depending on where the rail car is there, are some of the lines washed out, the rail lines washed out from, mudslides or derailments. Are they going through more cities? Because if they go through more cities, they're going to slow down and start up more. Are they on a route where they have to, pick up more cars or drop off more cars? So they're going to have more switching. What are some of the things that you're going to see? And then, of course, here it talks about how sea containers, once they get to the port, they get craned onto a truck, and then they get moved. So even that, crane pickup off of a boat and putting it onto a trailer or a rail car to get on the road or on the railway, that is also an opportunity for a shock event. So the, so this one, they talk about the COFC, which is like the sea container that gets put on a flat car, or the TOFC, which is trailer over flat car. You can see here the difference, right? They look different. This one still has the wheels, and once it gets here, it's going to get taken off and it's going to get hitched to a truck. But the way that they perform on a rail line is different because you've got the shocks that are in place here for the truck already. So it's going to be a lot different. Okay. So this is talking kind of what we've been talking about already. You've got a vibration table. We've already talked about the dynamics of the different axes and how it's hard to simulate that on to an actual truck ride. This is saying it's not really clear how you do that. And I agree with that, because every route is different. Every truck is different. The condition of the truck, the condition of the suspension, the condition of the sea container, those all make a difference, as well as, the condition of the railway. So, and this is another reason why it's important to, if you can do both tests, test along what that actual route is going to be versus the lab testing, you're going to get different results. So notice here, this says the results of that 1 hour on the table is going to be most of the time more damaging than putting it on the road. So remember before, and I mentioned, you want to do lab testing to look for catastrophic failure. So then you know how to protect your part. So, if you're doing vibration table testing, it's going to be harsher than many times than what you're actually going to see in the true shipping and distribution environment. So, this tells you, what you can compare things to, as far as the table and the roll time. So here the guideline is like about 1 hour on the table is equal to about 500 hours on the road. And 500 hours is a really long day for a truck driver. For them to get 500 miles in a day is really challenging. Like they say they can, but when you really look at how their day goes, they're not going to cover 500 miles in a day, because this is 70 miles per hour the whole time on a flat road. So maybe if they're driving through Nebraska to Colorado, they might hit 500 miles in 7 hours, but they've got to stop for breaks. They've got to stop to eat. They're going to hit traffic. And remember too, I think 60%. So if you are in I think Indianapolis, I don't know if that's changed, but they used to say if you have a warehouse in Indianapolis, you could hit 60% of the population in 2 days by truck. I think that's changed now. But if you're on the East Coast, it's a much more dense population and traffic's heavier. You're not going to get as far. So this 500 miles on the road, it really depends on where you are. So I think if you're like maybe in Indianapolis going west, you might be able to get that. But in general, most of the population is more dense on each coast, east and west coast, and in certain parts of the South. But it's going to be really hard to get 500 miles in 7 hours, because most of the manufacturing and the trucks are going to be driving through more densely populated areas. So, but from a standpoint of true mileage, you know, and as far as they cover that and what that could translate to, from a standpoint of testing and a vibration table, you know, I guess that would be a good guideline. So it's the 3E, which we looked at yesterday. They do not agree that the ride on the table is that is severe. So they say you take your let's say if you have 60 minutes on a table, let's just say 50 minutes, so we can make this easier. 50 minutes on the table, they're going to go 500 miles and divide it by 5. So yeah, well, let me redo that again. So if let's say you have if you're going to do 500 miles divided by 5, it's going to be 100. So that's, now you're saying 100 minutes on the table. Sorry. So yeah, this gives you 60 minutes and 300 miles on the road. So I'm just kind of thinking this out loud. But yeah, so this is saying that it's not as severe. But this just gives you an idea. You know, you want to use your lab testing to identify opportunities for failure, make sure that you're designing robustly, not over designing, but you're looking for where the vulnerabilities could be, understanding again what your profile looks like for transportation and distribution, and then, you know, try to make your lab testing simulate that as much as possible, and then design to failure, you know, to get product, their packaging design, so you don't have failure. And then from there, you know, test it again through the real distribution route before you approve it. Okay. We mentioned about the axis, you know, all the different axes, and that most of the shake tables are, you know, just omnidirectional. But this is an example of a table that has multiple, it can move in multiple directions. And I've seen these, you don't see them very often. In fact, I might have gone out to here, to this place in Troy, Michigan years ago, because they had a pretty big shake table. There, and we did testing for racks for rail cars, for engines going to Mexico. So I'm pretty sure this is where we went, but you can see they actually have like a whole control room for it. It looks totally different than the other shake tables that we saw earlier. And it's got the hydraulic pumps to get those different motions in there. And see, this one is used for vehicles because especially on the high-end vehicles like this one, it looks like it's a Lexus, but the high-end vehicles, one of the things that they use to distinguish, besides the performance of the motor and performance of the vehicles, one of the things that they use to give people the sense of luxury is noise reduction. So they will shake and vibrate the vehicles to simulate the road once again, to see how much noise is dampened by the interior design of the vehicle, as well as, you know, the squeaks, and, you know, what does the, you know, how does the vehicle suspension, how does the suspension protect people from all the noise. And here is one here. You can just get an idea of how big it is, because you see he is standing the height of this man is just hitting the floor of this cage, right? And that's a rack testing cage right there. Any questions, Brandon?
Nope, all good.
So have you seen any type of testers of this scale?
Yeah, I work with the vibration tables, and I believe we also have one of the bigger ones, the 6 different axes. So that's kind of nice. You mentioned it earlier about the being the poor individual who has to memorize all of the ISTA standards. Yeah, that was that was me for 7 months. So
I'm sorry.
it's all good.
But I'm sure it helps you now, because now when someone starts talking about testing and you're like, we don't need to do that, or yeah, we definitely need to do that, you have a
Mhm.
better idea.
Yeah, it's definitely useful right now because we're working on redesign. So they're sending over new packaging configurations. I'm noticing certain issues that I'm like, this wouldn't even pass a level 1 test on a vibration table. So yeah, it's
Mhm.
useful.
Mhm. See. Yeah, so I think that, every packaging person should work with, if not at a lab, but with a lab very, very closely for at least 6 months or a year at some point in their career. The earlier, the better. So
Definitely.
it makes a huge difference. Because now it's to, for me, it's just kind of ingrained. I may not even use the terminology, because I just know, like I said, you can look at it and say, this isn't going to pass the test. Because you just know it becomes intuitive after a while.
Definitely.
There's a little bit here about, non-automotive testing and using the recorders for vibration, to understand what it looks like for acceleration. And they talk about where accelerometers are placed, where you might want to place them in the truck. You notice here, they're going to be near some of the wheels. And then this is what some of those look like. This is standing for the surge. All the ones that say X, Y is going to be sway, and then the Z is going to be heave. And then the last 3 are going to be the roll, the pitch, and the yaw. So this is what these different profiles look like, as you go through the movements of it that simulates a truck. And you can see that X and Y are fairly similar at this point. And then here you kind of see that same point, the roll and the pitch are really the roll, the pitch, and the yaw look very similar to each other at this end. So usually when you are putting accelerometers in a truck, you're gonna do it for a longer period of time. Some people might do it for hours, but generally they're gonna put it on, to follow a truck and see what that movement looks like. And that's usually gonna take more than a few hours for that truck to move. And you can see here, it doesn't do a whole lot. And then you have an event with a bump. And you can tell by looking at this that, you have big bumps across. So this is my interpretation. At this point, here, 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 and here, this was an event that caused this to show up in 4 out of 6 of the graphs. So that tells me that that truck moved in multiple directions at the same time during whatever that event was. So this is what it looks like when you have bumps. They're taking this out because they really just want the bumps, because that is what is causing the damage during the truck ride. You know, the smooth sailing, you know, you hear people saying they want the roads fixed and that sort of thing. It affects the truckers quite a bit, because if every time they have an event on a bumpy road, they're more prone to damage. But if it's a smooth road, you know, now they're looking at things like stopping or sharp turns or, you know, things like that. But it eliminates some of those bumps, literally bumps in the road. Okay, so again, this is also, you know, you're looking at things other than vibration. This is that you're trying to simulate. I mentioned yesterday when I worked for a company that made servers, you know, putting something that would simulate going over a the dip that represented going into a freight elevator. So this is showing going over a bump. This probably, it could be a bump in the floor, maybe it could be an uneven floor. Maybe there's a point that, you know, things, you know, the level changes, maybe they're going down a little step in the floor. Is not enough to, you know, it's enough of a step down that it can be an event, but not so much that a fork truck can't get over it. So, you know, those are just some examples. What does that do to this pallet of bottles? You can see that they're now not smooth and flat. And, you know, is that an issue to put this with corner post and stretch film when you know it's going to be going over some sort of bump or step? So, you know, this is where accelerometers get used again, to see what it looks like, to see, you know, what does that shock event look like, and what direction is this moving? Are you looking at, you know, heave, serve, sway, or is it going to be more like rolling, pitching, and yawing? And they use that to input into the table for the 6-axis vibration. And that's where you get, like for this one, it's a wave motion. So that covers really chapter 3. I know we have, you know, one more day tomorrow, so we still have some time. I'm gonna go over the questions for homework today, but I think I'm gonna go back over them again tomorrow. And I will have some, like I mentioned before, have some of the information that is related to supplemental information for some of these tests, some of the testing that we have. So, you know, like I said, I'll post some of it, but I want to go over that as well. So, okay, so for number 1, if you're shipping lightweight sheet metal parts in rail cars and they're designed for heavy loads, you'll notice that the parts are going to rattle and bang and, you know, hit each other. Okay, if you're shipping heavy parts in the rail car, but it's designed for light parts, what do you think will happen to the parts? So again, you know, this rail car is designed for lightweight parts. How do you think that it will affect the rail car itself? You know, could it do anything to the rail car? Also, you know, if you've got lightweight parts that are shipping, and it's designed for heavy loads, you know, your shocks are made to absorb more weight. So that's why you see them banging and bumping into each other. Because it's kind of like being, you know, something is made to expect a lot of bounce and cushion. But if you've got heavy parts and they're going in a rail car, and that rail car designed for lightweight parts, is kind of the opposite, where you've got parts that are light. And trying to think of an example, a really good analogy here. In the parts, I'm just trying to think, if you have a car, let's say you have a car that is really cushy and you're, you know, hitting a lot of bumps. But it's not really meant to do that. You know, what could happen? If you've got springs or a shock for the vehicle and it's just made for, okay, here's an analogy, a golf cart, right? So if you've got a golf cart and the suspension is just really made to hold, you know, two people and your clubs, and you're on golf, you know, you're just on like a little trail for the golf, you know, on that, you're on the course, and it's pretty smooth, and there's not really a lot of bouncing. But let's say now you take that golf cart and you put it on the freeway, and now you put 5 people into that golf cart. Tell me all the things that you think could happen. You've got more people than is rated for, so you went from 2 people to 5 people. And not only that, but you, instead of putting your golf bag on it, now you all are carrying, you know, 15, 16-pound bowling balls for everybody. So you've, you know, added a lot of extra weight, and now you're on the highway that has potholes. And this golf cart was designed to drive on courses that are grassy, and they might be kind of hilly, but they're really pretty smooth. So that's basically what the question is for that one. For number 2, for and this one also for number 1, you know, I would say reference around, it's going to be around page 3. See. So yeah, I mean, let me read the first few pages of this. So you can read around for your rail cars, right? So number 2, for test number 1, if your EFW is 1,500 pounds, what fill weight is used for the third impact? Okay, now you're gonna need to understand what the weight increment is for that total weight of 1,500 pounds. And then you need to know what those different impacts are. So you can figure out the first impact, and then you have your second impact, and then your third one. So you'll need to do a calculation and figure that out. If you have any questions on that, let me know. But number 2 is the calculation. Please show your work on that one. Okay. Number 3, which this is regarding the RC9 test number 2. And you want to explain why test number 2 does not simulate fork tip impacts. Okay, so let's go here to test number 2 for RC9. The sidewall impact. So I'm going to read about this one again. And tell me why you think that, you got 2 4x4-inch wooden posts that are attached to the sled wall. And it's designed to simulate the fork trucks hitting the side of the container. So again, it's a simulation. It's designed to simulate. So in your own words, tell me why you think that it doesn't simulate the impacts of a fork tip. Okay. Any questions, Brandon?
Nope.
Okay. No pressure. You're you're the representative for the class today. Okay. Number 4, if the Ropac HD 45 48 34, which is the 48 inches in length, 45 inches in depth, and 34 inches tall, which is when you'd stack 3 high in a trailer. If you're running this according to AIAG test number 9 for RC9, what weight should you use to do this? And if you need some more information, you can go to Google and you can Google that particular container, the 45, 48, 34, and it's a Ropac. Okay, so one thing that you need to find out is the capacity from the manufacturer, what they say the capacity is. Let's see. So go back to number 9. And again, what you're looking for is you're looking for the capacity for that particular bin. And you can Google that and you should be able to find that out. And then though this can be stacked 3 high, I'm curious to know, how many, if you're doing it for 1, how much would it be for 2? So you're basically going to double that capacity. Number 5, this refers to test number 10 for AIAG RC9. Same container, that 45, 48, 34 container. A leg comes off during the 7th impact. How do you know what the drop height was for this one? So so the question is, which drop are you reporting you don't necessarily have to tell me what the height. Well, actually, yeah, you do tell me what the height is. And also, if it was damaged on the 7th impact, are you going to use that drop height, or are you going to use the impact for a different drop? For number 6, for these RC9 tests for AIAG, when they're done in individual totes, it mentions, we talked about they use 40 pounds for the test media for the handheld totes. The question is the test load based on EFW? Okay. And then number 7, is this one true or false? ISO 8611 pallet test number 2. When the pallet fails and doesn't return to its original shape after 2 hours from removing it, is this true or false? So let's go here and look this one up. Okay, so okay, this is pallet, again, pallet test number 2. You're going to go down to the pallet testing. And we want to know, does the pallet fail if it doesn't return to its original shape 2 hours after removing? And this is again in part B. So we'll go down to part B. Okay. So this talks about the compression load being equal to 50%. That's part of the question. And you apply that, and then your next part says deflection at the center of the pallet is measured immediately after reaching this load. Okay, the pallet is considered to pass this test if the center deflection after the 24-hour dead load test in part B is 1. If it's less than 2% of the span, just before the 24-hour 50% dead load is removed, and is less than 0.7 of the span after the 2-hour recovery period. So it's considered passing if it meets both of these, number 1 and number 2. So keep that in mind as you look at that question. Okay. And I just told you for pallet test number 1, I'm sorry. Okay, so pallet test number 2 is a repeat of test 1, but with the uniform load. Okay, so your criteria is the same for that one. Okay, so you're looking at 1 and number 2 for it to be considered a pass or fail. And then your next one is what hazard handling, transportation, storage does ISO 8611 test number 4 simulate? So test number 4, you want to determine the compression strength of the blocks or stringers, right? So, I mean, it's pretty rough, but you know, the pallet's considered to pass if the change in height is less than 4 millimeters, just before the load is removed, and then less than 1.5 millimeters after it recovers. So what is this simulating? In your own words. So based on, you know, what you see in the reading and the pictures, you putting a steel plate over the corners, you're trying to spread out that load evenly. You know, what is it that you're trying to simulate? Like, what does that look like? In real life, what are they trying to simulate? What type of damage? Where would this type of damage, where would it come from? Is that clear, Brandon?
Yep.
Okay. And then again, is it handling, is it transportation, is it storage? You know, what could it be? You know, what sort of hazard or hazards is that simulating? And then number 9 is a true or false. AIAG RC9 is a mandatory standard that is used by all automotive OEMs and tier suppliers. And it outlines the required test for transit. And then whatever your answer, true or false, is, you know, explain why you come to that conclusion. And then the last one is number 10. This is referring to the 6-axis shakers. And if you're trying to produce like a wave motion, like in this picture that we saw in the reading, what would you do? You know, which kind of motion would you use to simulate that? And we're going to go back here. Okay. So, so again, this is the fork truck that's carrying a pallet of little bottles over a bump. Okay. This is telling you right here, what is it doing to get the wave motion? And this happens with auto parts as well as, you know, non-automotive related parts. This looks like it's like barbecue sauce or beer or something, I don't know. But read that and find your answer. So I hope that was helpful for you all. Brandon, before we close today, any questions or anything?
Nope, no questions.
Okay. All right. So again, this is posted. The homework is posted. I posted that last night. So if you haven't already started looking at it, you know, check it out. I will go through some things tomorrow again with some supplementary information. And I'm hoping that if anyone has any questions, that they are sending emails or reaching out to me, so I can go over that during the lecture tomorrow. Also, you can go, you know, you can show up to office hours on Fridays and I can answer any questions you have. And, you know, try not to wait until the last minute to get your homework done, you know, because I just may not be available. Because I know, I'd say on Monday when things were due, I had a meeting. And when I got out of my meeting and I checked my email, I had several questions for people that turned the homework in like right on time. So, which is good to turn it in on time. But if you have questions, try to reach out to me. Ideally, if you have questions and you reach out to me on Friday during office hours or before then, that's the ideal time, because that, gives you time to maybe reread something that wasn't clear, gain some understanding, or go back and show your work if you haven't shown your work, or for some of the questions where you just have an explanation, like for example, number 10, or number 1, on the homework, have some time to explain clearly. I would like for you to write a small paragraph on, why you say that's what this is. If you have calculations, to show all your calculations for the homework. And I really think you're going to have calculations on number 2. And then you're going to have really minimal calculations on chapter 4. And yeah, I think that's it. Number 5, you might have a very quick calculation on number 5 as well. But in general, just be clear on your thought process on what you're doing. Sometimes just being clear in your thought process will help to answer the question, may clarify some of the things that you're looking at. So, but you guys have been doing a great job on the assignment so far. I know this is pretty challenging. It's a lot of work, a lot of information, because the world of automotive is totally different than consumer, for example. But it's really good because automotive, they are ahead with returnables. And I think, Brandon, just based on some of the things that you've said, you're working in industrial right now. And how has this helped the automotive background? How has that been helpful in industrial?
It relates a lot because a lot of the things in industrial production, so all of the things we're making, it follows like we just got done going over the whole assembly setup. So that's directly what I'm seeing every day in our manufacturers and production sites. And then the packaging, they kind of meet the same needs. You need something that's like rugged, that can protect your heavy products, and definitely with the testing procedures it relates, because a lot of the testing I did back in the lab was it was for smaller products. So I did small drop tests and whatnot. But when it comes to industrial, we're using the vibe table, we're using forklifts, using more of the 3E unitized pallet load test and ASTM. So I'd say it relates a lot.
Okay, good. I'm trying to make this relatable. I want to make sure that this is something that is usable for everyone. So, in areas where, the homework is heavy in theory, like today, which is great. And I think it gives you a really good background. But I'm also trying to put in some real world situations as well. So, okay, well, great. So tomorrow again, we'll go over some supplemental information. I'll maybe hit up some of the homework again if necessary. And I think that would be it for now.